Now I'm going to show you our last strategy, and it's actually my favorite, solving a system of equations by elimination. So what we're going to do is multiply one of the equations by a number so that we get the additive inverse for one of the variables. That being, if we had 2y, we would want the other y component to be negative 2y to cancel each other out. Then we solve for one variable, and we can use either of the equations to solve for the second variable and then check our solution. Again, it's easier done than said. So let's go ahead and give it a try. So when I'm looking at this, I'm seeing that these two guys have the same sign. They're both positive. However, these two, one's positive and one's negative. But this is 2y, this is 1y. So what I'm going to do is I'm going to multiply this top guy on both sides by 2. So we're going to end up with 4x plus 2y equals 14. So now I'm not even going to look at that anymore, at least not until I check my answer. So we're just going to add these two equations together. We get 5x, the y's cancel out, equals 20. Divide both sides by 5 and we get x equals 4. We can stick 4 into either one of these equations. I'm going to stick it into the top one, just because y is already by itself. We don't have to divide that way. So we have 2 times 4 plus y equals 7. 8 plus y equals 7. Subtract 8 from both sides and we get y equals negative 1. So that's our ordered pair, 4, negative 1. So now we'll check our answer. We'll check it in one equation. We'll plug 4 into the first one. 2 times 4 minus 1 equals 7. 8 minus 1 does equal 7, so that one's good. Let's try the other one. 4 minus 2 times negative 1 equals 6. Negative 2 times negative 1 is positive 2. 4 plus 2 equals 6. This is true, so this is indeed our solution. Got a few more of these that we can try. Let's see what we can do. So we have the same sign on the x's again, so I'm going to try to get the y's to equal each other's coefficients. So we have a 3, we have a 2. So I'm going to multiply this first one by 2 so that we get a negative 6. Multiply this one by 3 so we get a positive 6. So remember to multiply everything, not just the y's. So we'll have 8x minus 6y equals 18. 3 times 7 is 21x plus 6y equals negative 18. So that's pretty neat. Not only are our y's canceling out, but our constants over here are canceling out. So we have 29x equals 0. Divide by both sides by 29 and we get x equal 0. So let's plug 0 in for one of these. I'm going to plug it in this one because we have a nice positive y to deal with. 7 times 0 plus 2y equals negative 6. 2y equals negative 6. Oop, I'm getting ahead of myself. Y equals negative 3. So there's our ordered pair. Negative 3. So we'll check our solution. We'll plug it into the first one. 4 times 0 minus 3 times negative 3 equals 9. Negative 3 times negative 3 does equal 9, so 9 equals 9. We're good. Let's do the other equation. 0 times 7 plus 2 times negative 3 equals negative 6. 2 times 3 is negative 6. 0 times 7 is 0. Negative 6 equals negative 6. We are good to go. See, I feel like these ones go a lot faster than the substitution ones, generally speaking. But again, it's completely up to you which way you want to go about these. Let's look at the next one. So my first thought is get rid of these fractions. So I'm going to go ahead and just multiply both sides of the top one by 2. Just to start to get rid of the fractions. I don't like fractions. The bottom one, we have 2's and 3's, so I have to multiply it by 6 to get rid of all the fractions. So we have 2x plus y equals 12. Then we have 9x plus 4y equals 17 times 3. I don't know that one off the top of my head. 51. So we have a 2x, a 9x, a y, and a 4y. I feel as if we multiplied this top one by a negative 4, then our y's will cancel out. So what do we get? Negative 8x minus 4y equals negative 48. We'll add the other equation, 9x plus 4y equals 51. Sum those up. We get x, y's cancel out, equals 3. Once we got through all that multiplication, that ended up not being too bad. So what's our y going to be? Let's plug 3 into, let's do the top one because there's fewer fractions in it. So 3 plus 1/2 y equals 6. Subtract 3 from both sides, 1/2 y equals 3. Multiply both sides by 2, y equals 6. So that's our ordered pair, 3, 6. Let's put that into both equations just to make sure that we didn't make any mistakes. 3 plus 1/2 of 6 equals 6. 3 plus 3 equals 6. And yes, it does. That one's good. Let's try the other one. 3/2 of 3 plus times 3. 2/3 times 6 equals 17 halves. So this is 9 halves plus 6 divided by 3 is 2 times 2 is 4 equals 17 halves. So everything is over 2 except for this 4. So I am going to change that into an improper fraction. Turning that into an improper fraction, we get 9 halves plus 8 halves equals 17 halves. 9 plus 8 is 17, and it does equal 17 halves. All right, let's look at this last one. This last one is actually set up for us really well for substitution. So that's the way I would go with this one. But Let's try doing elimination, just because this is the elimination section and that is what we are supposed to be doing. Again, I want to get rid of this fraction. So I am going to multiply everything by 4. So we end up with 4y equals 12 minus 3x. We want everything to match up with this top equation, so we have to bring this x over so the x's line up and the y's line up so that we can more easily do our process of elimination. So we're going to add 3x to both sides, and we get 3x plus 4y equals 12. Well, that looks familiar. So if we subtract these, we're going to get 0 equals 0. Do you remember what that means from a few videos ago? That means there are infinite solutions. Because they're the same line. So go ahead, work on problem 22. There are quite a few of these to work out. I do believe that this is the best way to solve these most of the time. The only time I would say it's not is if you have y explicitly solved for you already. So go ahead, give it a try, and I will see you in the next video.